Okay, okay, let's talk about predictive parser, and what is a predictive parser, and a program for the given example. Uh, what A predictive parser is a recursive descent parser, which does not require backtracking. But we can also pull this off without using recursion by using an explicit stack. We use this normally to determine the function that need to be added for a after the non-terminal value, in an array. And okay, let's get to the code now. uh, I have four global values, namely int I top, which stores all the I is the recursive bit I'm using, and top, which stores the top value, and it's the stack, the character stack, and the input. This is the IPs where I store the input. And I used three functions: push, pop, and error. Uh, Push, pop, and error, and this is the driver code. The driver code, I print I use the print function to print the grammar so that the user will understand, okay, this is the grammar, and we should be passing a string which should be given in this grammar, or which can be passed or not. Okay, then after getting this, uh, then we add a append two extra values to the string, which being a dollar and a backslash zero. Dollar indicate, I mean, we use dollar to indicate the end of an array or a string, a string, or and in the stack we use it to determine it's the end of a stack. And the push function, and the backslash zero means it is an abbreviation for null value. So if I mean, it means after that it's null. uh, so first we for us okay for so This is the example I'm taking, I plus I. So this will be the input array, I plus I, dollar and backslash zero. And okay, first we'll push dollar into it, because we need a dollar at the end, so that it signifies the end of the stack. And then we push e's, because and then we push e. And now we have three conditions to follow, and all the three conditions are the three conditions are, top is equals to terminal. Top is a terminal value, and the terminal value being a dollar. So since I'm using an I plus uh, I plus I as the input value, I plus I as the input value, uh, and the top terminal, I plus I as the input value, I and plus are the terminal values. And dollar is also another terminal value, which is not part of the actual input string. And then all the others, which are f, t, and e, which are present in the grammar, are called as the non-terminal values. So we have these three conditions, where the top is a terminal value, which is a dollar, which being a dollar, and the top, which is a terminal value when end is not a dollar, and top is not a terminal value. And each content has its own set of conditions to, I mean, statements to carry out. So since we passed, we pushed e into the a dollar and e into the stack, and e is on top of the stack. So e is not a terminal value. So that we know it. So now let's see. So okay, e is not a terminal value, and I initialized I to zero in the first. So in the input string, I is mm, I is the first, I mean zero, I is in the zero index, so yeah, I is zero, so p of I is I, and so this being true, this will be printed. Okay, let me run and show you. So I plus I is a I plus I is a, so these are the conditions. Okay, now, so okay, first I plus I, this being true, it will print E tends to T E dash. So yeah, here you can see T tends to E T dash, and then it will pop the first value out. So it will pop E out and pushes A and T. It pops E out and pushes A and T. So now T is on top of the stack, and T is also not a terminal value. So we'll just look for another condition where T is on top and P of I value is I. So this is a condition where this will be true because top value is T and P of I is equals to I, and then the parser, I mean the condition should be T tends to F T dash. T tends to ft dash. So you can see here, and then we'll pop we'll pop t out on the top of the string, and then we'll add two new, I mean we'll push two new characters, one being b and the other being f. So now f is also not a terminal value, so we'll go down, look at where f and I are there. So here this is true. So yeah, you can see, and then we'll just pop f and push we'll just pop f and push I into the on top of the stack. So now I is a terminal value, so the second condition is true. Now the where is the second condition? Okay, then p of I is equal to the stack, so the um, a terminal value is equal to the stack. So we'll just move on to the next terminal value. So in the string I plus I, the next terminal value is plus. So yeah, so it's a when now the terminal value is plus, and we increment it to that, and we'll pop the I off. Yeah, I mean the I. Okay, next, since now B is on top of the stack with a plus being the TI value. So let's see. So okay, this will be true, and T T is an epsilon, and T dash tends to epsilon will be the that condition, and now B then just pops the first value, and now A is on top of the stack. If A is on top of the stack and the IP of I value is plus, then this will be the condition which will execute. And yeah, as you can see, E T dash E dash tends to plus T E dash. So we'll just push A T and A T and plus, and the top of the stack, plus being a terminal value, the second condition will be true, and again we'll increment it to I will be incremented further, and it will be again I now. And it pops off, and then T is the new top value. And now where is T? Okay, T and I. So this will be true where T will be popped off, and B and F will enter the stack. T will be popped off and B will enter the stack. Okay. B and F, and F and I. This is the statement for F and I, where I will be on where okay, we'll push well, I mean we'll pop F and we'll push I, and I is also a terminal value. So we'll go to the second statement, and now again it is incremented. When it is incremented, you can see the next value is dollar, Next value is dollar, so we'll just pop this off, and next we'll move on to the next, this one. So in this stack now, B is on the top, and B is on the top, and is a, this one. And dollar, B and dollar, it's B and dollar. So this is when top of the stack value is B, and I of P is dollar, then a T dash will be epsilon. So there will be no value this thing. So we'll just pop it off, pop B off, and then if it's an A, and if the top value is A, and the IP value is a dollar, then E dash tends to epsilon, and this, and it A also pops off, and now it's and we only have the dollar left in the string, I mean in the stack, so it's a terminal value, and if it, so this will execute. So if it's the case, so, and when that's the case, we successfully pass the string, since there's no errors, or I mean no errors in the sense there's no uh, you know string character which is out of the grammar. So it successfully passed it, and it gave us all the, statements which functions which need to be added to the non-terminal value. And now as we can when we proceeded further, we'll go to the next bit, which is backslash zero, and which will end the while loop. That's it. Thank you.